Assalamu alaikum respected students. Today we will discuss very interesting topic, second law of thermodynamics. Basically, second law of thermodynamics is the fundamental principle in the physics, also used in chemistry, especially in physical chemistry. Second law of thermodynamics basically deals with the directions of natural process, particularly those involving heat, energy and work. It establishes certain processes are irreversible, introduce the concept of entropy, which quantifies the degree of disorder and randomness in the system. Basically, entropy can be defined as the degree of disorder and randomness in the system. This law have several equivalent statements. We will discuss step by step further. First of all, we discuss why we need to establish second law over the first law of thermodynamics. What was the flaws in first law which was covered by second law? First, review their difference, then we can understand easily the concept of second law of thermodynamics. What is the focus of first law? First law only focus conservation of energy. We know that very famous statement of first law of thermodynamics: energy can neither be created nor be destroyed. Rather, it can be converted from one form to another form. Okay, it was the first law of thermodynamics, simplest statement. So, first law only focus on the conservation of energy. What is the focus of second law? Second law focus on direction of energy flows and entropy, basically. That is the main focus of second law of thermodynamics. Main idea: energy is constant. What is the main idea of second law? Entropy always increase in spontaneous process. What are the allowed and or permission process in first law of second law? All the energy changes reversible or not. It can focus on the calculation of all the energy changes in reversible process. Mostly maybe irreversible process. In second law, only process where the total entropy increase. It focus on that process, that reactions in which entropy is related. What are the restrictions in first law? Nothing, just tackle energy, all types of energy. Second law, what is the restriction? Impossible conversions, e.g. 100% heat into work. After this basic concept, we will discuss this concept, impossible conversion, in detail. What is the analogy? Analogy is basically first law of thermodynamics is the back statement. What is the total energy? Second law, it is a rule book. What is allowed, what is not allowed. Process possible or not possible. It is spontaneous, not possible. Yes. In which direction restriction will continue. Main focus of second law. What is the core concept of second law? Only we will focus only second law. What is the core concept? Core concept of the second law of thermodynamics is that natural thermodynamic process. In all natural thermodynamics process, total entropy of system and surrounding either increases. Mostly in natural process, you can say spontaneous process are always increasing their entropies, or maybe remain constant. These are, if entropies remain constant, that is possible for the reversible process. Natural process are irreversible process, or in other words you can say that's the spontaneous process. So in the spontaneous process, natural process, you can say irreversible process, entropies increases. Okay. This law basically explain why energy tend to disperse, why system naturally move toward the state of greater disorder, or in other words you can say why the systems are moving toward the state of greater entropy, unless external force is applied to maintain this order. Why heat flow from hot reservoir to cold reservoir or hot object to cold object. Why perpetual machines are impossible. Perpetual machines, we will discuss later what is a perpetual machine. Why certain process occurs spontaneously in one direction but not the reverse. These are the main subjects of second law of thermodynamics. Second law of thermodynamics explain these reasons. Okay, now we will discuss the different statement of second law of thermodynamics. For example, Sadi-Carnot statements, Clausius, Rudolf Clausius statements, Lord Kelvin and Max Planck's statements. They are the different statements of second law of thermodynamics. First is the Clausius statement. The Clausius statement is basically entropy-based statement of second law of thermodynamics. Heat cannot spontaneously flow from cold body to hot body without external force being performed. Very best example of this statement is refrigerator, in which we provide the electricity power, in which heat is moved from cold body to hot body. Hot is the definitely our surrounding, fridge is our cold body. Okay, this form focus on the natural direction of heat transfer. For example, if we place the hot object next to the cold one, heat flows from the hot object to the cold one until thermal equilibrium is reached. Okay. In all natural processes, definitely it is the natural phenomena. Heat always flow from the hot to cold, but in the reverse, it is flow from cold to hot. If we wanted to flow heat from cold to hot, definitely we have to perform some work. It does not occur spontaneously, because if heat is flowing from hot to cold, it means entropy increases of the system. If heat is required to transfer from cold to hot, it tend to decrease the entropy. To decrease the entropy of the system and surrounding, we have to work, we have to apply some force, we have to this work in the form of mechanical work, in the form of electrical work, or maybe other types of works. This is the Clausius statement of second law of thermodynamics. We will discuss this statement in mathematically in the next video. Also, you got all the simple concepts of second law of thermodynamics. We will see you in next video. Take care. Bye bye.